In this lesson, we're going to solve applications using a system of equations. Suppose that a firm manufactures radios and sells them for $50 each. The cost incurred in the production and sale of the radios are $200,000 plus $10 for each radio produced and sold. We're going to write the revenue expression and the cost expression, then find the break-even point. How many radios must be sold in order to turn a profit? The first step is to define any variables that we're going to need. We need to know how many radios are going to be sold and produced, so we're going to let R represent the number of radios. That makes my revenue expression 50R, since we're selling the radios for $50 each. My cost is then $200,000 plus 10R, since the costs are $200,000 plus $10 for each radio produced. In order to find the break-even point, we're going to set the cost and the revenue equal to each other. The break-even point is when there is no profit and no loss. My equation is then 50R is equal to 200,000 plus 10R. We can now solve this equation since it's one equation and one variable. We're going to start by subtracting 10R from both sides, and we get 40R is equal to 200,000. Then we can divide each side by 40. That leaves us with R is equal to 5,000. That means that the break-even point is 5,000, so that when 5,000 radios are sold, there is no profit. In order to have a profit, that means we need to sell more than 5,000. Because if we sell less than 5,000, we're going to incur a loss because we have that huge fixed cost of $200,000. So more than 500 radios must be sold in order to have a profit. After splitting his time between two jobs, Kerry has to make a choice between the two. His stocking job at $8.50 per hour has health insurance that costs $15 per week. His fuel pumping job at $8.75 an hour has health insurance that costs $19 per week. How many hours does Kerry have to work for the two jobs to pay the same, and under what circumstance should Kerry keep the pumping job? We're going to let H represent the number of hours worked. So stocking would be 850H minus 15, since the health insurance is going to cost him money. The pumping job is 875H minus 19. In order to find how many hours need to be worked for the jobs to pay the same, we're going to set both of those expressions equal to each other and then solve the resulting equation. I start by subtracting 875H from each side. So I get negative 0.25H minus 15 is equal to negative 19. I can then add 15 to both sides and divide by negative 0.25. That leaves me with H equals 16, so Kerry has to work 16 hours for both jobs to pay the same. That also means that at 16 hours, the cost of the health insurance really isn't going to affect his bottom line of his paycheck. So in order for Kerry to keep the pumping job, he should work more than 16 hours. And we could show that using the table on our graphing calculators. In y equals, I'm going to put the stocking job into y1 and the fuel pumping job into y2. We can then look at the table. We see at x equals 16, y1 and y2 are the same value, which is what we showed algebraically, that the jobs pay the same after 16 hours worked. If he worked less than 16 hours, we notice that the stocking job has higher values than the fuel pumping job. That has to do with the cost of the health insurance. Even though the stocking job pays less per hour, the health insurance is also less. So if he works less than 16 hours, he should keep the stocking job. If he works more than 16 hours, we notice that the fuel pumping job, since it pays more per hour, is then going to result in a higher paycheck. And the more hours that he works, you could see that the fuel pumping job will pay more and more. So if Kerry works more than 16 hours, then he should keep the pumping job. In this last example, during strenuous exercise, an athlete can burn 12 calories per minute on a treadmill and 8.5 calories per minute on an elliptical. If the athlete burns 325 calories in a 30-minute workout, how many minutes does the athlete spend on each machine? Since I'm looking for the values of two different items, the number of minutes on the treadmill and the number of minutes on the elliptical, I need to have two different variables. We're going to let T represent the number of minutes on the treadmill and E represent the number of minutes on the elliptical. Since I know that there's a 30-minute workout, T plus E is going to equal 30, since T and E represent the total number of minutes on each machine. Next, we need to take a look at the number of calories. I know if I have 12 calories per minute on the treadmill, I can multiply it by the number of minutes I spent on the treadmill to get the total number of calories I burnt on that particular machine. So 12T plus 8.5E is going to equal the total number of calories that were burned, which is 325. You can choose to solve this by either substitution or elimination, but since we have T plus equals 30 as a very simple equation to solve, I'm going to solve using substitution. So T is equal to 30 minus E. Then we could substitute into the bottom equation. 12 times 30 minus E plus 8.5E is equal to 325. We're going to distribute and then combine like terms. So 360 minus 3.5E is equal to 325. We're going to subtract the 360 and then divide by the negative 3.5. That gives us E is equal to 10. So 10 minutes were spent on the elliptical, and since we had a 30-minute workout, the remaining 20 minutes were spent on the treadmill.